In this example, we're going to look for the IRR for two different projects and then calculate the crossover rate for those projects. So the internal rate of return for project X is 14.5%, and the internal rate of return for project Y is 13.94%. Now we're going to look at what is the crossover rate for these two projects. The crossover rate is the rate at which they equal. So the rate at which they equal each other. So we're going to look for the difference between the cash flows. So X minus Y and then we're going to calculate the internal rate of return of those cash flows. So the crossover rate for these two projects is 9.25%. Now we're looking at a project there. We're trying to evaluate a project with that costs $38 million. We're going to make back $56 million in year one, and then in year two, it's going to cost us $9 million to terminate the project. We have a required rate of return of 10%. We want to calculate the net present value and the two different internal rates of return because of the end of project negative cash flows. So the net present value at 10%. So this project has a positive net present value of $5.4 million. The internal rate of return then, in this case, we're going to ask Excel to make a guess for us so that we can calculate the two different internal rates of return. And so you can see that we have two internal rates of return. This happens anytime that we have a cash flow with negative signs and later in our project year, instead of just positive cash flows for the entire project. That will always cause us to have two internal rates of return. In the case of those kinds of projects, we should not use the internal rate of return to make decisions, and we should just use the net present value. This is a comprehensive problem where we're comparing two projects. They both have a required rate of return of 13%, and we're going to do all of the methods of calculation from the chapter. So first is the payback period. So we have project A and project B. So project A, take the initial cost plus year one cash flows, and then the cost remaining at the end of year one plus year two cash flows, the cost remaining at the end of year three, at the end of year two plus year three cash flows. And then in year four, we're going to make more than what is left in year three. So remember, for the payback period, we then need to divide what's left at the end of the year divided by the cash flows for the next year. So project one is going to be paid off in 4.34 years. So project B, we have our initial cost plus year one cash flows. And we have $21,100 left, and in year two we're going to have cash flows of $21,800. So it's going to be fully paid off in year two. So we're going to take what's left at the end of year one and divide by year two's cash flows. And the payback period for project B is 2.97. The net present value of each project, so the rate is 13% for both projects, for cash flows plus the initial cost. So our net present value formula, 13% rate, project B's cash flows, and then we add project B's initial cost. Calculate the internal rate of return for each project. And the profitability index. So for the profitability index, we need the present value of the cash flows divided by the absolute value of the initial cost. So we have the present value of the cash flows. So divided by, and because our cash flow is as a negative number and we need it to be a positive number, we're going to put a negative and then select our initial cost. Net present value, no, rate first. Divided by the initial cost. So we can see that everything except for the net present value suggests that we select project B. It has a faster payback, it has a higher internal rate of return, it has a higher profitability index, although not by much. And so everything except for the net present value tells us that we should pick project B. However, with a mutually in this example, we're calculating the